Okay, in this video I'm going to show how to select and size some media filters for a water project. This is a quick filtration tool that I made, but I think I'm going to continue to try and work on it and improve it and have other engineers look at it before it's final. But I'll use this tool to select the number of media filters we need and do the size and plan for the backwash and all of that. And this is for a treatment that is filtration and chlorination only. So nothing about sedimentation or anything like that. So the first thing you do is enter your design flow rate. For Litamali, the flow rate was about 6.8, but once we add the filters, it's going to reduce a little bit. So I'm going to use a design flow rate of 6.5. The next thing you do is choose the number of filters you want in parallel. This is up to the designer. You can try several different options. I think between 1 and 4 filters in parallel is reasonable, and they all have their advantages and disadvantages. If you use 4 filters in parallel, then you'll have a lower flow rate through each filter. So you'll select a smaller filter, and then you can design your backwash where water can flow forward through 3 of your filters and then backwash one filter. So and then if you want to use one large filter, that's okay as well. 2 filters. The key to think about is how you're going to backwash your filters. Backwash requires very high flow rates compared to forward flow. So you need to achieve a high flux rate of between 30 to 40 meters per hour. And then that will correspond to a certain flow rate depending on how big your filter is. So you need to think about, the key is to be thinking about how am I going to backwash these filters properly. So right now let's just start with 1. You can, this filtration tool is designed to allow you to enter in one option, see what it looks like, see what the results are, and then change it until you get what you want. So if I have 6.5 meters cubed per hour, I have only one filter, one media filter. How big does that filter need to be? Well, the determining factor is flux rate. Through a pressurized filter, if you look at table 2.2, you need a flux rate of 8 to 12 meters per hour. So what size filter is going to give me 8 to 12 meters per hour? Well, you can use this chart to figure it out. Here are the filter sizes in inches, and here is the flux rate range you need to achieve, 8 to 12, and here are the design flow rates that correspond to that flux rate and size. So I'm looking for my design flow rate in this chart. My design flow rate is 6.5. So, okay, here we are. 6.5 is in between 5.3 and 7.9. So I would need 36 inches, 36-inch filter to get between 8 and 12. So put 36 inches in here, and it shows me my filter flux rate, 9.9, and that's between 8 and 12. So that's good. If you don't even have to use this chart, you can just enter in a number of inches that you think will work, and then this calculation of flux rate will check to see if your flux rate will be between 8 and 12 meters per hour. So let's say I wanted to see what's it going to be if I use one filter with 24 inches. Well, I'm going to have a very high flux rate, 22.3. And that's too high. So I can check, well, maybe 30 inches, 14.3. Still too high. Okay, maybe 36 inches. Okay, that's good. What if I try 42 inches? That's too low. So I need to make it smaller. So now, if we want to use one filter, we need a 36-inch filter. And now we need to look at our backwash. So because we only have one filter, we can either choose a parallel filters backwash methodology or a pumped or elevated tank backwash methodology. Just for reference, the LWTS is an elevated tank backwash. There's a backwash tank of clean water sitting above the filters, and then when you pull the manifold valve, water flows from that elevated tank through the filters backwards to backwash those filters. That's an elevated tank backwash. Alternatively, you could install a pump to pump water from a tank through the filters, and then you can control the flow rate and flux rate you want by doing that and designing it properly. And then the third option is parallel filters backwash, where you have multiple filters. Water flows forward through the three of the filters and then backwards through one of the filters, and backwashes that one filter at a time. And then you switch it up. And so you always have water flowing forward through three filters and backwards through one filter to get the desired backwash flow rate. The reason you have to do that is because the backwash flow rate is much higher than the forward flow rate. Again, so obviously, since we only chose one filter in parallel, our option is either pumped or elevated tank for backwash methodology. So now we're going to check what is my backwash flux rate or my backwash flow rate that I actually need to achieve through this filter. So when I backwash my filters, what flow rate do I need to get in those filters to get a full backwash? Well, the answer is if I'm getting a flux rate of 30 to 40 meters per hour, then that's a sufficient backwash. So I enter in the flux rate that I want to achieve first. And then the spreadsheet will calculate the flow rate that I need to achieve based on that flux rate. So if I want to get a flux rate of 30 meters per hour through my filters during backwash, through my one filter, I need to backwash it at a flow rate of 19.7 meters cubed per hour, or 328 liters per minute. And that's a minimum. That's your minimum. Your maximum is 40. So I could go up to 438 liters per minute of backwash through my filter media. I advise that you at least put something a little higher than 30, just to give yourself margin for error when you're designing a backwash. So I'll choose 32. That works out to 21 meters cubed per hour, or 350 liters per minute. That's the flow rate we need to achieve during backwash. So we need to think about how you're going to achieve that. This tool doesn't design a backwash system for you or help with that. You can use EPA net. You basically select a pump and put it in EPA net, and a filter, and put in some piping, and model your filter. A filter should have about 1 meter of head loss during backwash, so it's not a lot of head loss during backwash. You'll have and then you can design it like that, or you can use EPA net to design an elevated tank backwash. I think you typically the only thing there is you just need to use a large pipe. Even if you need a very high flow rate, that can be achieved with a large pipe and about 3 meters of elevation, a minimum of 2.5 meters of elevation above the ground level where the filters are installed. So I think that's what we will do for this. But let's check out some other options instead of just one filter. Let's try 2 filters. If we use 2 filters in parallel, okay, 20-inch filters is too small. Let's try 24-inch. Okay, a 24-inch filter will give me the right flux rate. So it's 24-inch or something close, probably at least 24-inch, maybe 30-inch is too large if you have 2 filters. So if you have 2 filters, 24-inch would be the right flux rate. And then let's look at the backwash. If I want to get 32 meters per hour flux rate, now this is the backwash flow rate per filter. Backwash flow rate per filter. So now I only need 9.3 meters cubed per hour per filter, or 156 liters per minute. So you can design a backwash scheme that will backwash at 156 liters per minute in EPA net. Or you can design one that will backwash 2 filters at the same time at 156 liters per minute, or a total of 312 liters per minute. So that's up to you. And now let's check if we want to do 4 parallel filters and do a parallel filters backwash. Okay, first of all, we have 4 parallel filters. Let's see, 16 inches, that's a little too small because the flux rate is a little too high. It's better to aim for the lower end of this range. 8, 9, and 10 is good if you can. Or just better capacity of the filters to handle the turbidity. The higher turbidity, the lower flux rate your filtration can manage. And at extremely low turbidities, you can actually design for a very high flux rate. But for our projects, 8 to 12 is appropriate. So, okay, 4 filters of 20 inches would be 8 meters per hour flux rate. So that's perfect. If there are 18-inch filters available, that could be an option as well. And then let's look at the parallel filters backwash. So if you're using a parallel filters option, your backwash will be different. You don't focus on row 15. Instead, you focus on row 14. So, and basically, row 14 just tells you, with your setup, if you have 4 filters and you're using 3 filters to backwash 1 filter, so forward through 3 filters and backwards through the 4th filter for a backwash, then this is the flux rate you can expect to achieve, 32 meters per hour, which is perfect. 32 meters per hour is in our range of 30 to 40. So, so that's how you select your number of filters and your filter diameter, and check your flux rates. Both forward, you need to have 8 to 12, and then during backwash, you need to have 30 to 40. This basically designing for these 2 targets designing according to flux rate and sizing the right way and designing for the correct backwash flow rate. These will make our filters perform well. It will reduce the issues of having a very high pressure loss, pressure drop across filters, and will increase the lifespan of our filters so that they don't continue to build up more and more clogging of turbidity or clogging of sediment in the filters. Having the proper backwash flux rate prevents clogging over a long period of time. So I think there's one disadvantage here I want to mention for the parallel filters backwash. The disadvantage for a parallel filters backwash is you don't get any chlorine in your backwash. If you do a pumped backwash or an elevated tank backwash, you will have chlorine in your backwash tank because you'll be using treated water as your backwash. You'll have chlorine in your backwash tank, and the chlorine is important during the backwash to disinfect, not only clean the filters, but also disinfect the filters to prevent any kind of biological growth. The parallel filters cannot do that because the parallel filter backwash scheme occurs before the water is chlorinated. So you don't get any kind of chlorinated backwash. That's one disadvantage. The second disadvantage is, particularly for Indonesia, is the filters that you procure in Indonesia are already, the plumbing is already arranged for switching from forward flow to backwash very easily, and that works with a elevated tank backwash. The plumbing is much simpler. But if you want to arrange your valves and plumbing for 3 filters to backwash 1 filter and go to the drain, it's a little more complex and will take some work to develop that solution. So that's another weakness of parallel filters. But these are obstacles, but they're not something that should totally eliminate parallel filters as an option. You can do the work to come up with the plumbing solution for parallel filters. We do have diagrams for that, but it may be a procurement issue. You'll want to look into procurement, whether you need to procure parts from the USA or you can find the right valves locally. That will be a big factor. The second thing is for a disinfection during the backwash. That can be resolved by adding disinfection of the filters to your regular maintenance. It doesn't need to be done every day. It doesn't need to be done every backwash. It should be done at least once or twice per year. You could arrange for it to be monthly. That would be up to you and what you think the operators can handle. So those are some things to consider. For simplicity, for this project, I'm going to recommend a pumped or elevated tank backwash, which means we need to achieve 32 which means we need to enter our flux rate we want to achieve. I'll put 32. I'll add a little more. I'll say 33 meters per hour. A little more margin for error there. And then you can choose how many filters you want. If you only want to backwash 1 filter at a time and you have 4 filters, you only need about 100 liters per minute, 110 liters per minute. Or you can use 1 or 2 filters. I think I will recommend 2 filters. It gives you a moderate flow rate for backwash. Fewer filters are easier to manage than lots of filters. But I'll let you make that decision for this project, Effendi. Okay, so for me, I've chosen 2 filters, 24 inches. You'll get a flux rate of 11 meters per hour. And you'll need to backwash each filter at 160 liters per minute. What's the next thing to look at? Oh, I should have gone over these steps. The steps are written out, but I went through them in this training video. Enter the design flow rate, select the number of filters in parallel, and select the filter diameter. Check the filter flux rate. Choose a filter diameter and quantity that will allow the system to operate in the correct flux rate range. So basically check this to make sure it's 8 to 12, and then change these numbers until you get a number between 8 and 12. You can use table 1.2, filter diameters and flux rates. That's this table here, to find the correct filter size if you need to. This row 9 shows you the flow rate per filter, so that's the number you would look for in this chart. Then select the backwash scheme you want to use, and then for parallel filters, check row 14 to see if your design will achieve the required backwash flux rate. So if you're using parallel filters, check this row. If you're using a pumped or elevated tank backwash, enter the desired backwash flux rate for your filters. So you enter that here, and then check the flow rate that you will need in your backwash. The next tab here is just a quick filter media calculation. So calculating the total mass of filter media that you need. So you just enter in your filter media. Right now, the option we recommend is zeolite. I think that's the best option. So this sheet doesn't have any more options than zeolite. Enter in the density. But maybe in the future we could add other options if we find other good options in the market. Then the number of filters is automatically entered from the previous tab. The filter diameter comes from the previous tab, 24. You enter in the height of the filter media you want to use. I just looked up zeolite, and the required height was 30 to 46, 30 to 45 inches, I think. I'll make sure that's correct. So I put in 36 inches. You may use 30 is the minimum you should use, but it depends on your filter. You want to fill up your filter but leave enough freeboard. And then enter your margin. So how much extra zeolite do you want to procure? You may not want to procure the exact weight of zeolite that you need. You might want to procure a little bit extra. So I put 10% extra. And so this means you need 440 kilograms of zeolite media for your project. So I hope this is a helpful video, a helpful tool for selecting your filters.